All right, you guys. So, moving on to numbers 12 and 13. So again, don't be a dud. Make sure you have your periodic table and a calculator in front of you. And follow along, for crying out loud. Don't just sit and listen to Mr. Huderberg talk about chemistry. You do chemistry, try to learn this. This is here as a resource for you, all right? We're going to focus on critical thinking numbers 12 and 13, right? This will be the last little bit of new information before we move into the skill practice, which, as the name implies, is just practice of the stuff we've already been through. All right? So, we want to be able to calculate the molecular formula from the empirical formula, and what that means in this context. So let's say, for example, number 12, we got an empirical formula, which just means the ratio. It is not the actual formula necessarily, right? Is NO. That means we have an even ratio, 1 nitrogen for every 1 oxygen. Now, that could be NO as the empirical formula. Molecular formula, empirical formula could be the same, or it could be N2O2, or N3O3, or N4O4, question mark, ... right? All we know at this point is that we have a 1-to-1 ratio, right? And that 1-to-1 ratio could play out in any way, right? So we need to try to figure out, well, what actually is the molecular formula? Is it 2-to-2, 3-to-3, 4-to-4, what? All right? And so the way we do that is we essentially just follow the steps outlined for you in parts A, B, and C. So first, let's do the molar mass of the empirical formula. So empirical formula is NO. So 1 nitrogen and 1 oxygen. So 1 times 14.01 plus 1 times 16.00. So basically 14.01 plus 16 is going to give us 30.01. Okay, as the molar mass of the empirical formula. NO, 1 nitrogen, 1 oxygen. All right. Now, this right here, the molar mass of the molecular formula, the actual molar mass with the subscripts included, is 60.0. All right. So basically, what we're going to do in step B is we're going to figure out, well, if the empirical formula has a molar mass of 30, how many times do I need to multiply the empirical formula by to get to the molecular formula? And this is all we'll do. We're going to take the molar mass of the compound over molar mass of the empirical formula. And that's going to give us a whole number, typically, all right? And what this would be in this case is the molar mass of the compound is 60. So 60.0. The molar mass of the empirical formula we just calculated is 30.01. So basically, right, we're just going to go with 2. All right? So what that means is I'm going to take my empirical formula, which is NO, 1 nitrogen, 1 oxygen, and multiply it by 2. So N, if we imagine a 1 and an O1, if I multiply each of those by 2, my molecular formula is going to be N2O2. All right? So again, there's a kind of a lot of steps. None of the steps are very hard. It's just easy to get lost in the shuffle, right? What do we need to do? First, we need to know the molar mass of the empirical formula. Step 1, right? 2, as long as we know the molar mass of the molecular formula or the compound itself, right, we're going to divide the molar mass of the compound by the molar mass of the empirical formula, and that should give us a whole number. And that whole number ought to tell us what to multiply the subscripts of the empirical formula by to get the actual molecular formula. All right? So let's put number 11 and number 12 together into one single question, which is what it would look like right here in number 13. All right? So, first of all, we're going to take the percent composition, right, to calculate empirical formula. right? Then once we know that empirical formula, we can apply that to step B. So this is like number 11 we just did, and this is kind of like number 12, right? We're going to put all those together. All right, so for number 11, it says, number 13, what is the empirical formula of a compound whose composition is 85.7% carbon, 14.3% hydrogen? So all we're going to do is going to go the percent, which is 85.7, over the mass of carbon, which from the periodic table is 12.01, right? And when we do that, we should get 7.14 if I round that to 3 sig figs. All right, and so this is for carbon. Right. We're going to do the same thing for hydrogen, 14.3 over 1.01, and that is going to give me 14.2. Right? Now, that's going to be for hydrogen. Now, if I divide this, so the smaller of the two is 7.14. So I'm going to divide both of these by 7.14. And what I'm going to get is a 1 and something pretty darn close to a 2 right there. Right? So what that means is I have 1 carbon for every 2 hydrogens. So my empirical formula is CH2. All right? Now that I know my empirical formula, right, I can then figure out the molecular formula based on total mass or molar mass of the molecular formula, which is 56 grams per mole. All right, so here's what we're going to do. We're going to take 56 grams, right, which is the molar mass of compound, over the molar mass of CH2, which is going to be 12.01 plus 2 times 1.01. Right? So we're going to get 56 divided by 14.03. And that should come out to a nice number of 4. 56.0 divided by 14.3. Yep. I get 3.99, but close enough to 4. All right? So what that means is I'm going to take my subscripts times 4. So we're pretending there's a 1 there, because it does mean 1. I'm going to take that number times 4 for my molecular formula, so it's going to be C4, right, H8. Skadoosh.